Hello, welcome to the part 4 of our demonstration of the design and analysis of an axial fan. We've actually come to my favorite subject, computational fluid dynamics. And of course, Ansys offers very strong CFD tools such as Fluent and CFX. And I'm going to particularly talk about CFX, which has unique capabilities for turbomachinery flow simulation. So what we're going to do is we're going to go transfer data to new and select CFX. This is going to transfer our mesh generated at the previous step in TurboGrid, and so we can then start CFX. We're going to hit the setup button, which is going to bring up CFX pre. And CFX has 3 different modules. As it comes up, let me explain. The pre-solver, and there's a CFD post component. So here we're going to now quickly see how to use CFX pre, particularly for turbomachinery type applications. So as you can see, we can see the outline of the mesh. And what I'm going to do is I'm going to start assigning flow physics, boundary conditions to set up the CFD model. Well, normally, a user has to go select each and every surface, assign boundary conditions. However, CFX has this special tool which makes life very easy when you switch to turbo mode to define specific turbomachinery problems. So here we want to work on a fan. Our coordinate frame wraps around the z-axis. It's a steady state solution. So using this wizard, we're gonna define our problem very easily. So let's look at our components. We have a block for R1. Our rotating speed is 3000 RPM. And we hit next. In the next step, we need to do a little bit of physics boundary conditions. So we're going to be sending air at 25 degrees C at atmospheric pressure. Let's use a total pressure at the inlet and a mass flow rate per passage. So that should be 2 divided by 29 passages, which is about 0.069 kilograms per second. I'm going to hit next. Here we have the interfaces, and as you can see, they are automatically captured. So we really don't have to do anything but hit the next button. Next step is defining boundary conditions, and again, these are all readily defined for us. So at the inlet, previously we also specified the total pressure, and at the outlet we specify the mass flow rate. And as easy as this, the setup is pretty much done with using the turbo tool in CFX. So once the setup is complete in CFX pre, we can shrink the window, we can go to solution and double click it. This is going to start the CFX solver. I'm not going to talk much about the solver. What it does is essentially create a new window where you can track the progress of the iterations. And once the flow solution is converged, we're going to take a look at the results in the next session.